Okay, this is the 5.1, 5.2 study guide. Okay, so if you have like bases and you're multiplying, then you add the exponents. So our like base is y. So you're going to add the exponents. 12 plus 8 is 20. So it is y to the 20th. Okay, number 2, same thing. We're going to give this exponent, this variable, an exponent of 1. Our like base is y. So 1 plus 8 is 9. So our answer is y to the 9th. Okay. We're going to do these piece by piece. Do your coefficients first. Negative 8 times negative 6 is positive 48. Then we're going to do x squared times x to the 4th. Our like base is x. Add your exponents. You get 2 plus 4 is 6. And then we're going to do our y's. First we're going to give this y an exponent of 1 just to be safe. And then we're going to say y. You're multiplying like bases. You add your exponents. 1 plus 6 is 7. So it is 48 x to the 6, y to the 7th. Okay? Anytime you have a 0 exponent, anything being raised to that 0 exponent is 1. So in this case, everything is being raised to the 0 exponent, so our answer is just 1. Okay, here we go. So in this case, what is being raised to the 0 power? Just the x. So this basically says negative 6 times x to the 0 power. Now x to the 0 power is 1. So this basically says negative 6 times 1. And we know negative 6 times 1 is just negative 6. So our answer here is negative 6. Okay? Here we have 5 being raised to the 0 power, but you still have to deal with this negative out here. So 5 to the 0 power is 1, but you have that negative out here, plus negative 11 being raised to the 0 power, and that's 1. So negative 1 plus 1 is 0. So in this case, your answer is 0. Excuse me. Number 7, we're going to go ahead and give this a to the first power. This is the quotient rule. Dividing like bases, you subtract the exponents. So this becomes a to the 4 minus 1, which is just a cubed. Okay, here we're going to deal with the x's first and then our y's. Quotient rule again. Dividing like bases, you subtract the exponents, so you get x to the 4th, because 10 minus 6 is 4, and then y to the 11th, because 13 minus 2 is 11. So your answer is x to the 4th, y to the 11th. Excuse me. Okay, we're going to do our coefficients first. Negative 14 divided by 2 is negative 7. And then you have x to the 9th over x to the 4th. So we're going to, our like base of x, 9 minus 4 is 5. Then we have a like base of y, 10 minus 7 is 3. And then you have a like base of z, and 4 minus 3 is 1. You don't have to write the 1 if you don't want. So you have negative 7 x to the 5th, y cubed z. Then we have x to the 10a over x to the x squared. So since you have like bases, you can subtract. So you have x to the 10a minus 2. Unfortunately, you can't subtract those because we don't know what 10a minus 2 is. So your answer is just x to the 10a minus 2. Alright, same thing here. We have a like base of x, but you're going to have 9a plus 6 minus 6a. Well, you can combine your like terms here. 9a minus 6a is 3a, and then you have plus 6. You can't combine any more like terms, so you end up with x to the 3a plus 6. So number 12 is 5 to the negative 2. So remember, if you have a negative exponent, you drop it like it's hot. So this becomes 1 over 25. I skipped a step there. I should have gone 1 over 5 squared, which then you know is 1 over 25. Okay. Now here, what is being raised to the negative 3 power? Just 5. So you're going to leave the negative in the numerator with the 1, and then 5 is dropped to the denominator. So it becomes negative 1 over 125. So only the 5 is being raised to the negative 3 power because there are no parentheses. All right, here we have x cubed over x to the 6. Now we can do this one of two ways. You can look at it as, you know there's a difference of 3 x's, and there's more x's in the denominator, so you can just leave it down here and put a 1 in the numerator. Or you can do the quotient rule, which says 3 minus 6 is equal to x to the negative 3. And then you know x to the negative 3, you drop it like it's hot. So you get, oops, you get 1 over x cubed. Either way, you're getting the same answer. Okay, here, piece by piece. 40 divided by 5 is 8. Okay. And then we have, let's go ahead and give this x a 1. So we have a couple things we can do here. We can go ahead and take this and drop it like it's hot, and take this and raise it to the top, or we can do the quotient rule. Let's go ahead and drop it like it's hot and raise it to the top. So if I drop it like it's hot, you get x to the 8th and x in the bottom already, in the denominator, and then raise it to the top. You already have y to the 6th in the top, and we're keeping y to the 1st in the top. So then you have 8 in the numerator already, and then since you're multiplying like bases, you add the exponents, so you end up with y to the 7th, over, and in the denominator you're multiplying like bases, so you get x to the 9th. So you end up with 8y to the 7th over x to the 9th. Alright, write in scientific notation. So your decimal point's here, so you move it until you have a number between 1 and 10. So 1.3 is between 1 and 10. So you say 1.3 times 10, and then you count how many humpies you have. So I have 1, 2, 3, 4, 5, 6, 7. And because I went to the left, it's positive 7. Now we're going to the right. So we have 1, 2, 3, 4, 5, 6. 9.0516 is not between 1 and 9, but it's between 1 and 10. So 9.0516 times 10, and it's how many humpies are there? 1, 2, 3, 4, 5, 6. So it's to the negative 6 power because you went to the right. Alright, let's try this one. So they want us to go backwards now, so we're going to take 8.2436 and we're going to move it 4 spaces to the right, which ends up giving us 82,436. Okay, so let's do this one. I've got 7.0219. Because it's negative, I'm going to go to the left. 1, 2, 3, 4, 5, 6, 7. So my decimal place is going to be here. So I need to put a 0 for every humpy. And then you put a 0 in front of it. So it's 0.00000070219. Alright, so I have x to the negative 4 to the negative 3. So before I drop it like it's hot, since it's a negative times a negative, when you take a power to a power, you multiply them together, and this is actually just going to become x to the positive 12. So instead of dropping it like it's hot and then having to raise it back to the top, might as well just go ahead and multiply them first and save myself the hassle. Okay, if you take a fraction to an exponent, the numerator gets that exponent, and the denominator gets that exponent. So 5 cubed is 125, and 2 cubed is 8. Now that can't be reduced, so that's actually your answer. Okay, so if you have an exponent, it has to go to every piece of the puzzle. So not only is it going to the numerator and denominator, it's going to every piece in the numerator, okay? Since there's nothing I can do inside the parentheses first, I'm going to go ahead and give the 4 to every piece. So it's 3 to the 4th power times x squared to the 4th power times y cubed to the 4th power all over z to the 4th power. So 3 to the 4th power is what? 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay, so we have 81. And then remember, if you take a power to a power, you multiply. So x to the 8th, y to the 12th, because power to a power, over z to the 16th. And that is your final answer. Okay? Now here, remember, be careful. Only the numerator is being raised to the -2 power. There is not parentheses around the denominator, so leave it alone. However, because the entire numerator is being raised to a negative power, you could drop the whole thing like it's hot. It's up to you what you want to do. I think we should go ahead and do that. So what we're going to do is we're going to leave a 1 in the numerator, and then we're going to drop the whole numerator like it's hot. So what we're going to do is we already have a 2x y cubed down there, and we're going to take 4x y to the -2 squared down there. Okay, so 1 over, leave 2x y cubed alone, and then you're going to say 4 squared x squared, because we're giving this 2 right here to every piece, and then y to the -2 squared. Okay, so that's 1 over, still just 2xy cubed, haven't done anything to it yet, and then over here we have 16, because 4 squared is 16, x squared, and this becomes y to the -4th, because -2 times 2 is -4. So let's start multiplying together here. 1 over 2 times 16 is 32. And then x times x squared, give this x a 1. So we're multiplying like bases, becomes x cubed because you add the exponents. So 1 and 2 is 3. And then y cubed times y to the -4th becomes y. If you add the exponents, you get 3 plus -4. 3 plus -4, or 3 minus 4. Excuse that. So 3 minus 4 is -1. So y to the -1st power. So the only thing we have left to take care of is this y to the -1st power, because you can't ever end with an answer with a negative exponent. So we just need negative exponent in the denominator, raise it to the top. So you end up with y to the 1st power, which we won't write, over 32x cubed. And that is your answer. Okay? All right, here we've got the entire thing being raised to a negative power, so we're going to go ahead and drop it like it's hot first. So this is 1 over 3x to the -2, y to the 9th, z to the -2, all squared. Now I need to make sure that each piece down here gets a squared. So then I have 1 over 3 squared, x to the -2 squared, y to the 9th squared, and z to the -2 squared, which is going to give me 1 over 3 squared is 9. If you take a power to a power, you multiply exponents, so you have x to the -4th, y to the 18th, z to the -4th. So I have 2 negative exponents. So remember, negative exponent in the denominator, raise it to the top. So you end up with x to the 4th in the numerator and z to the 4th in the numerator, all over 9y to the 18th. least. Be careful here. Notice there's separate parentheses. It's not one big parenthesis. So the numerator is being squared, the denominator is being raised to the negative power. So let's go ahead and do it this way. We're going to give everything in the numerator a squared, everything in the denominator a negative 1. So we have 3 squared, x squared, y cubed squared, and z to the negative 3 power squared, all over 4 to the negative 1 power, x to the 6th to the negative 1 power, y to the negative 1 power, z to the negative 4 to the negative 1 power. Okay, so when you take a power to a power, you multiply, don't forget that. So 3 squared is 9, x squared is just x squared. So if you take a power to a power, you multiply. So you get y to the 6th, and then z to the negative 6. All over 4 to the negative 1, x to the negative 6, because multiply, y to the negative 1, and z to the 4th. So if you want to deal with the negative exponents, we can do that. So this one needs to drop it like it's hot. And this one, and this one need to be raised to the top, right? Blue goes to the top, red goes to the bottom. And all the ones that are in black just stay where they're at. So in the numerator we have 9 x squared y to the 6th, and we're adding all the blue ones up there. So times 4 times x to the 6th and times y to the 1st. And then in the denominator we have z to the 4th is already there. And we're going to bring down, what is that, z to the 6th? And is that it? Yep. Okay, so let's multiply. 4 times 9 is 36. And then we've got x squared times x to the 6th. Like bases, add the exponents. So it's x to the 8th. And then we have y to the 6th and y to the 1st. So add the exponents. Y to the 7th. Over z, like bases, add the exponents. Z to the 10th. And that's your answer, guys. You guys have a great night. Good luck studying. I'll see you tomorrow.